the participant can raise their questions in the question box, or if they want to write something, they can write in the chat box. I request a participant to write their questions on the question box. So let us start, Yatin. Should we start? Mr. Jarek, are you ready? Should we start now?
Yes.
Okay. So on behalf of ICI New Delhi Center, I am Pradeep, Garg, chairperson, and I welcome all of you for this webinar. In ICI Delhi Center, we have started a webinar series on new products and technologies. The idea is basically we have lots of technologies being used in our construction industry right now, and lots of these technologies and products are very new, and we don't have knowledge and experience on those items. So our endeavor is to bring those knowledge banks to you, so that you get knowledge not only about the product, but how to implement it and how to use it. So in that series, we conducted first seminar 2 months back, in which we talked about post-installed rebars, and it was a very well received webinar. Now today we are going to talk about this dry stone cladding, or what we call it, popular term is dry stone cladding, but when I say cladding, it's not only a stone, it can be other forms of cladding material also. It can be tiles, or it can be PVC metals also. So we have been facing, Yatin, I think there's a lot of flickering happening in the video. Are you finding that problem? Or is it running okay?
No, sir. It is running okay, sir.
Okay, fine. So, so today we are going to talk about this new technology. I will not call it a new technology, because we in India, particularly North India, we have been using claddings, particularly stone claddings in our walls for a long time, for many years in fact. But over the years, as our mines are shrinking, and we are getting less and less stone, so we have moved from stone masonries to the claddings, and then from cladding we have been doing mortar-based cladding. Then there were problems in those stones falling down, and so many problems we were having. So we moved on to clamps and mortar. Now then we moved only on drywall with clamps only. Now we have evolved to a new technology, which is a worldwide accepted technology, where we call it dry stone cladding with backup frame and with clamps. So there are many advantages in it, which we are going to talk about. We have experts from Europe. Mr. Jarek is there with us. We have Mr. Jitendra with us. They have worldwide experience in this technology, and we have invited them to share their experience and knowledge. They come from Blick systems, and so before we get into the webinar, I'd like to share a little bit about the ICI and its activities. So Indian Concrete Institute, I think most of you are aware what Indian Concrete Institute is all about. We are a pan-India professional body, non-profit organization, and we organize this kind of knowledge sharing and experience sharing with our fraternity. And this New Delhi Center is also active for the last many years. And I will request Yatin to play the one audio video of ICI, which is a 4-5 minutes audio video. It will give you a good idea of what ICI is involved in. So Yatin, please play it.
Civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the cause of disseminating knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training programs, webinars, and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies, and practices. ICI's program Deminar is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus, the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users, and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations, and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS, focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its student chapters. There are more than 300 students chapters all over the country, and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes, and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable.
Yatin. So I request all the participants. I know many of you are already the ICI members, and those who are not ICI members, we request them to join ICI, take the life membership, and you have to log into our Indian Concrete Institute website, and then you will have option of membership, joining a membership, and it's a very smooth and simple process to join. So we request those who are already not part of ICI membership to please join ICI. And now I hand over to Yatin to introduce our speakers for the today. And before I do that, I request all the participants to please note two things. All of the participants are muted so that there is no disturbance when the presentation is going on. So participants are requested to write their questions, whatever question you have during the presentation, in the QA box, which you can see at the bottom of your screen. And at the end of both the presentations, we will one by one we'll take up a question for experts to answer. And in addition to that, Yatin is going to do a poll also. You can see a poll icon also. So there will be a pre-poll, and then after the webinar, there will be one more poll. So we request all the participants to be interactive and to participate in the poll. And with this, I hand it over to Yatin to introduce the speakers, please.
Thank you, sir. Good morning, everyone. We will be learning from two learned speakers today. First speaker of the webinar is Mr. Jarek Gruszecki. Mr. Jarek is CEO of Blick, Poland. His area of expertise are quarry operations, proper block selection, apart from geology and petrography. He has worked on projects in Poland, Germany, UK, and Scotland. Apart from these, he is also involved in several Asian projects, including the prestigious Surat Diamond Bourse. Second speaker of the webinar shall be Mr. Jitendra Ghag. He is currently working as DGM Design in Blick System India Private Limited. Mr. Jitendra has total experience of 26 years. He was also involved in the design of the famous Burj Khalifa in Dubai. Before handing it over to our esteemed speakers, we would like to conduct a poll. The poll is to assess the professional and academic demography of the attendees. I request you all to please take part in the poll. The poll is visible on your screens now.
Please tell them how to do the polling.
Please click on the poll button on your screen, and the first question is, please let us know more about your profession. You can select your profession from the options given. Around 72% of our attendees have voted, around 60 people. Most of our attendees are structural engineers, followed by consultants, general contractors, architects, and students. Results of these polls will help our speakers to optimize their content for this webinar. Now I request Mr. Jarek to please start the presentation.
Morning, hello everyone. I would like to thank you, Pradeep sir, for invitation, and also choosing the very important and interesting topic, which is transition of traditional to modern technologies in the facade industry. So start. So just at the beginning, I would like to summarize, let's say, 3 common facade concepts, because in my career, I found out few projects where these concepts were mixed. So there was on the facade some combination of details which used solutions from these 3 concepts, and the final result was a little bit away from expectations. So this is a very important point that we are on the same page. And then I will try to go through 3 main critical loads and fixing points which have which play a major role in design and also design life of the facade. Considering the sources which I was using, this was many details through my career, but in general, very important or very interesting is literature from German Natural Stone Institute, which can be converted on the concrete. And in this presentation, I also used a lot of data related to concrete, because designs of the facade is covering not only natural stone, but natural stone is in my heart from the childhood. My father opened a company few decades ago, and we ran a few quarries. Majority it was soft stone, and this is a good point, because sometimes we are mixing the stone like one family, and it is very useful when we split this into soft stone like sandstone, travertine, or limestone, and hard stones like granite, basalt, quartzite. This will help us in the later stage of this presentation. So we run also limestone, and I was working from at the beginning of my career a little bit in the quarry, only watching and taking part, and then I was working physically also in the factory. So I have a lot of knowledge regarding to the processing of the stone and how to deal with it, about details production. And then my interest was to develop some solutions which are useful for fixing on the facade, because I noticed a lot of malfunctions or damages on the facade, and then certification. So in these areas, I could be helpful, but definitely if I hear some interesting questions from you, I'm ready to also learn a little bit from you, and welcome also students. I got a question about before the webinar from one of the technical consultants related to this topic, and I will just use some of answer on the question. It will go through my presentation. So I would like to start from first typical concept of facade, which is wet cladding. And this is, I hope, known. A lot of you know this system. This is just using cement adhesive and fixing the tile to the wall. In Europe, there was a time when 2 or 3 companies certified this system, and it was the main ingredients, or it was built this way that stone tiles could be fixed to the insulation, not directly to the insulation, because there were few layers, but it could be fixed to the insulation. Maximum weight of the stone was 40 kilo per square meter, 5 to 8 kilo per tile. And this is very important, because I noticed that in some projects this limitation is crossed, and then results of this exercise is different. Sometimes panel breaks, sometimes panel fell off. The next limitation of this system is that the stone, it has, let's say, the panel which is fixed to the wall has to be permeable. So this is very important, because in areas where we have temperatures drop below 0, the water changes, the vapor water changes its stage into water, then it's frozen just in the layer of the glue, cement glue, and final in final result, these panels fell off from the wall. It is a very common mistake. And this system has also limitation regarding to the maximum panel size, which is related to 40 kilo per square meter or 5 to 8 kilo per panel. So we cannot fix bigger tiles than 600 by 300. And now a little bit disclaimer, small disclaimer. Yes, I have in my experience facade where bigger panels were used. This is related to very detailed analysis and choose of proper fixing glues, because this 5 to 8 means that usually typical cement glue we use is able to transfer 5 kilo. And about 5 to 8 years ago, it was I remember, last project with wet cladding. We were using larger panels, which were additionally anchored, mechanically anchored, and that panels were about half a square meter. But the cost of the adhesive was about 50 to 60 euro per 15 kilo bag. And this is very important point, because usually installers use the same cement glue and expect different results. So this is about first concept of the facade, which is common. This is wet cladding. The next one is masonry vented facade. In this facade, we have already cavity, which is just below the face of the facade, and this cavity is vented. This is very important, because wet cladding is also very fragile. Also, I mean, it can absorb the water from the ground, and then it is very easy to for bacteria and glands to attack this facade, and we face some important reduction in the performance of the facade. So in this masonry vented concept, we also use soft stone majority. Insulation is thickness of the insulation varies between 50 to a little bit more. The maximum we were using is about 150, 180 millimeter insulation in Europe. We use insulation. External wall thickness, and this facade is built from thick stones. They are not big. The blocks called ashlars are not big, but the thickness is average thickness is typical, let's say 100 millimeter. And we have, which is very important, I think, for Indian market, for Indian area, for this area, that we can use cornices which have big overhang and protect the facade from the rain. About that, I will talk a little bit more later. Then the height of the blocks is between 140, because this is the typical thickness of the seal, to 440. And also you can find facades which are built from bricks, and also only decorative elements are used from stone, like window frames. But very important point here is that seals which are used in this system, they have big slope. The flash of the seal is much more steeper than normally, and also it's steps. And typical detail, which is a must, is a water drip. And I noticed that it is not always used here in this area. Weight of elements can vary, typically about 20 to 40 kilo, which is related to health and safety regulations. But all these cornices are much heavier. But so this can be also installed. And both these systems, wet cladding and masonry vented concept, they have one common big limitation, which is related to the adhesive itself. It contains water, so we can install panels and build a facade only if the temperature of the environment and also the wall and stones which are built is above plus 5 Celsius. So I notice also sometimes it is the air temperature is plus 5, but still because of during the night drop of the temperature, the the stones are a little bit frozen, and sometimes installers use still install the facade, and then this bonding is not effective. Also, for both these systems, the limitation is that we cannot replace the panel. So summarizing all of these cons of these both systems lead us to rain screen. And in this system, we can use bigger panels. Rain screen can offer you bigger range of materials, not only stone, but you can use concrete, GRC, UHPC, you can use ceramic, HPL, acrylic materials like solid surface. It can be also ceramic glass or even laminated glass. Insulation thickness, it can vary. In India, you don't use insulation, so then the cavity is about 90 millimeters where is positioned the structure, and the cavity is about 30. Oh yeah, okay. In India, you have more, but typically cavity is between 30 to 50 millimeter. Minimum panel thickness is, I would say, 10 millimeter, with big tendency to reduce it to 8 and then to 6 with different results. But the minimum thickness of panel is 10 millimeter for secret fixing, which I will talk about it later on. And now I would like to also include one important point, because ventilated facades, which are built from natural stone, according to the German regulations, they can use thickness. You can use thickness 40 mil minimum for soft stones, and soft stones you already know which are these, and 30 millimeter for the hard stones. So granite is minimum 3 centimeter for the pin type, and the sandstone, limestones 40. For bigger panels, you need to use much bigger thickness. You increase the thickness. So the disadvantage of these fixings, let's say pin type, is that we can use this fixing points only around the panel. So on vertical or horizontal joints, we cannot use it behind. So also advantage of that solution is we can install very big panels. Very big panels, in my opinion, is this minimum floor to floor, or let's say minimum 1800 high. Fixing method is mechanical. I saw a lot of also in this webinar, there are a lot of structural engineers. This is very important for you, for them, because it happens very often that the chemical bonding, like cement bonding, was, let's say, optimized. So for to increase the bonding speed, sometimes it happened that installers, I don't want to talk about that particular projects, but it happened also that they add some stronger cement to increase the speed, or they add mix this bonding to reduce the speed because it's, for example, too hot. And this doesn't make the structural engineers very happy, because all of these calculations, they don't correlate with the reality. But in this rain screen, in the rain screen system, we have mechanical fixing. So whatever the structural designer will assume, or what kind of data they will use for the calculations, it is correlated with the real conditions. And also in this situation, we don't have the limitation about the minimum temperature. Okay, this is related with health and safety regulations. I took the part with one of the project where it was very, very cold. I think more about between 10 to 15 Celsius degree. And the installation took part. So the team every 2 hours had to change to warm up and so on, but the installation took place. And the panel replacement is also possible in this systems, but this is related to structure. About that I don't want to talk right now. Mr. Jitendra Ghag will explain you more about that. So just to confirm that it is possible to install very big panels. This is example from Africarium Zoo, where in 2014 the world's largest panels were installed. The size of the panel was 6.5 by 3.6 in thickness of 12 millimeter. Total size of the facade 6,500 square meters. And here you can see UHPC made in Pelhřimov in Czech Republic. This was about 16 millimeter, and the panels were also big, not as big as before, but floor-to-floor size. So summarizing, we can find definitely successful references of all of these solutions: wet cladding, masonry vented, also rain screen. I think that the majority of failures or damages which we can find in every country, this is not about only that let's say these systems enter very strong Indian market, but this is, you can find the malfunctions, let's say, or damages in many countries. I will show you in a moment examples. And so that, as of now, I think we know about these three basic solutions. And right now I would like to go to the challenges which stay in front of these facades, because we should be aware about that. I have chosen three for you, for this market, for this climate conditions, from many which are acting on the facade panel, and a lot of forces want to destroy our facades. We need to protect somehow it. The first one is the thermal cycles. So very typical question I sometimes get is zero joint gap. But we need to remember that the panel is exposed to thermal changes. And for example, in my country, we use about the difference of the temperature between winter night, which sometimes can reach minus 20 degrees, and midday or afternoon during the summer, the black panel can reach even 80 degrees. So we have 100 degree the space where the panel starts to is growing and shrinking as per local temperature. And this affects definitely the life of the panel. Sometimes we have enough space that the panel can freely shrink and grow, but sometimes it is not like that. And then we can find such a picture where here we can see GRC panels about 3 meter high or 2.5 meter high, which bend exposed on these thermal cycles, thermal differences. So what we see here, the panel bend, the value of this, how big bend is about 35 millimeter. So the panel bent such a way that exposed the cavity. Right now it is repaired, so it is safe. But this is very important for you to be aware about these situations. The next, maybe I will not talk about particular projects, but for your information, this is in Poland. This facade is, I think, already replaced, because I got this picture for consultation some while ago. This comes from UK. So you see also limestone tiles, which are fixed on the curve and also protected against the not to fall down. So rain screen panel can be fixed in three ways. The typical is pin type, which I think many of you know because this is very common here. And the next one is curve, and the most advanced is undercut anchor. the difference for the considering the pullout of this or performance of this fixing is very big, because we have made the comparison test in Heron sandstone, golden heron, for German market. On the German market is known like Hockenauer sandstein, and in 40 millimeter sandstone we reached 700 Newton pullout. Curve presented about 1200 and undercut 5000. So this is a big difference. If you see the space between undercut and pin type, there is a lot of comfort. So that's why we can install thinner panels and also panels which are bigger. And the difference between these two, pin type and curve, is that both of these fixings they can support panel only on the edges. Pin type in vertical and horizontal joints, and curve only in horizontal joints. There are some ways where we could support the panel also on verticals, but I don't want to talk right now, because this is very complicated, more complicated detail. However, undercut, it can be supported on the back side, the whole surface. So the world's biggest facade panels you saw just a minute ago, it was supported by 72 fixing points instead of 2 or 4, let's say 2 in pin type and or curve. So this is very important aspect. And also undercut anchor is much more safer during the installation, because it can, I don't want to go right now more into technical details of this particular fixing, but it gives more comfort during installation for installers, much bigger tolerances we can use during drilling, installation, and so on and so on. So, not to scare you, but here you can see straight away where fixing points are located. This project is in Poland. Here we can see that the lateral loads which are acting on panels were too high, or the fixing was too small, or the panel was of a much lower flexural strength, and we can see 2 panels broken and 1 undercut, 1 pin type fixing is also broken. Germany. The next load which is acting on the facade, which is wind-driven rain. Unfortunately, I was not facing the monsoon period in India, but I know I've got the information this is very heavy rain. And if we combine together wind and rain, we get something like wind-driven rain, which is acting on the facade. So how it is working? That normally the rain which is driven by wind, the wind is blowing on the wall, and especially on the rain are exposed top edge and corners of the building, because in the central part of the wall, the wind doesn't go through the building. It has to pass it by, or so the wind goes down or up, depends on the central point. So the rain goes directly down. So in the masonry vented system, we have this advantage that we can use cornice with big overhang, seals with also bigger overhang, steep slope of this flash part and so on. So this wall is much better protected than the wet cladding. Also the rain screen can give you also much bigger protection. So what happens if these assumptions we didn't apply to our design? In this situation, you see that there is no slope on this cornice. So these 3 points which I mentioned, you can use it and they are working. So there is no slope, The splash water also is affecting the panel above the cornice, and we see that the cornice is working generally well because panels below the cornice, they are clean. So I found, I met last time Professor Marek Dębisz from Academy in Krakow, Mining Academy, Technical University of Mining in Krakow. And he wrote a very interesting technical assessment, which is related exactly to this topic. So after reading this interesting literature, I found out that loss of flexural strength can cross 30% of the technical parameters of the stone, which is huge. Lastly, I also took part of consultation of a project which after 6 years from the installation, the whole facade has to be replaced. It was exposed on heavy rains, and the technical parameters of stone dropped such a way that facade of 6,000 square meters of facade has to be replaced. But you can find much more examples of damages caused by wind-driven rain. One of very common is this Helsinki Hall. In here we see Carrara marbles, which were affected by rain, humidity, and thermal cycles. And these panels also are bent and has to be replaced. So if we consider how important or how critical is the change of the temperature in combination with humidity, you can see that this is really critical. So summarizing this webinar, my part, we know. Oh, I lost one. Sorry, I just lost some. Find out that I lost somewhere the slide. So comparing these three systems, wet cladding, masonry, and rain screen, we see that the rain screen can deliver you much more space regarding to protection against wind-driven rain. It can give you much more freedom in the design of panel size. You can use really big panel size, and also range of materials used for the rain screen is much larger. Facade height, wet cladding is limited to 20 meters of the application because of this bonding. In some countries, you can find projects which are higher than 20 meters and are still using wet cladding, but this is rather, I would say, exception from the rule. But by limitation of this 20 meter of the installation wet cladding, I understand certified systems. So I'm not including in my webinar exceptions that, okay, some projects were using bigger panels and are still there. So this is happening definitely, but in this case, I consider only certified systems like from well-known companies. We're using Dickerhoff Sopro products, which are very good, and support from this company. This is not advertisement, so don't get me wrong, but the quality of products from this company was very, very good, and also technical support from them is very, very good. Material choice and fixing reliability is also higher. So right now, I would summarizing this part. You already know that these differences between wet cladding, masonry, and rain screen exist, and they are important. Loads acting on the facade, then also rain screen, we can use the biggest panels, and wind-driven rain, especially in your climate conditions, has to be also protection against it has to be analyzed. So definitely we need to use the water drip, bigger, steeper angles of the seals, and also angles of the copings on the parapet walls. So I hope that translation from traditional or common systems to modern will not look like this one, which before was wet, and probably right now we can consider this as dry cladding. And from my side, that's all. Thank you very much. If there are any questions, I'm ready to answer. Let me go just to the question from some technical. I don't know the name of this person, but he's asking that in Jawahar, Kalakendra is 50 millimeter stone used today. Practice is 12 to 18. So yes, this is according to the rules that the 50 millimeter. I don't know what kind of stone. I don't know this building, but generally, if this is 50 millimeter fixed on the pin type, this is as per rule. And today we are able to install 12 or 18 millimeter panels because of undercut. We cannot mix it. Sometimes people use, let's say, 20 or 30 millimeter bigger panels still use the undercut pin type or curve, which is not okay. So definitely, each fixing for each material has to be tested. So this is nothing which we can calculate. There are some mathematical models, but by default, each fixing we have to test by each material. So we have a few hundreds of tests already made for undercut. So I can confirm that in undercut strong granite you can reach even 12 kilonewton easily. So this is 1.2 ton, one fixing point. This is very significant load. Then whatever we try to fix up a clamp, the sedimentary stone has a tendency to split out, resulting into the loss of anchorage. Yes, definitely, because even the granite is showing difference in the load when we test it cross cut or vein cut, that you can find even 30% in granite, let's say Szczegom from Poland. That the difference in the flexural strength is there. So definitely it has to be marked and controlled, the anisotropy, how the panel is fixed. And also some panels are not allowed. You cannot fix with pin type or curve. For example, typical is slate. It is forbidden to fix the slate with on pin type or the curve. You can only use undercut or visible fixing through the panel. So I think this is the problem. If this helped you in your question.
Mr. Jarek, may I suggest we have another presentation, then we do the question answers?
Sorry. Right now I give voice to Jitendra. Thank you very much.
Then I'll read the question and you answer it, okay?
Yeah. Yes.
So thank you, Mr. Jarek, for your presentation. It was very interesting. To summarize for our participants, Mr. Jarek talked about the three systems of cladding, mortar base. Then he talked about pin and curve and undercut, and the advantage of undercut system. He said we can have larger tiles, we can have thinner tiles, we can have variety of material, not only stone, we can have soft stones and other materials also. Then he talked about when we are designing what are the issues they are related to thermal impact, and then he gave lovely slides and examples where the tiles have in fact bent because of thermal effects. Then he talked about the impact of cladding on rains and winds and wind-driven rains. Then he gave excellent photographs and live examples of how the if the cornice are not properly sloped, then what will the impact of it on the tiles, on the cladding? And now Mr. Jitendra is going to talk about how the undercut, the system itself, how the dry stone cladding system or the ventilated facade system is to be installed. He is going to talk about that. Welcome, Mr. Jitendra.
Sure. Just wanted to add, Pradeep sir, just there was also a difference between
Thank you, Jarek. And thank you, Mr. Pradeep and Sir Yatin. Give me this opportunity. Hello, everyone. Actually, I will show you today the undercut fixing, how it is done the fixing actually, how the undercut system is work in the building. So first, I will start that how this is the actually project which is Surat Diamond Bus, one of the world's largest office space, and has the area of approximately 200,000 square meter. That is 2 lakh square meter. In this project, if you see, there are actually three type of the stones are used. One is this red khada, which is actually you are seeing in the fins in the buildings in the front, and these towers around the glasses there is a white ceramic stones are used, and at the soffit also there are stones. In the tower, if you see, there is actually these lightings and the jali type of the perforation stones you are seeing. This called actually the stone jalis. These are coming at every tower actually, and there are 9 towers in that buildings. Plus there are the gates also, 9 gates are there, where actually the stone is fixed under the soffit as well. So here, this building actually experienced 2 cyclones, that is happen in actually in the 21, that is Nisarga, and after that Taukte. And this is already, there is no issue happen with the stone cladding. So I will show you now. There are actually how the system is fixed around the, or the design actually, how this design is happen around the stone cladding area. As Mr. Jarek shown in the last video, that the critical part of the actually around the window is the jams and the soffit stone. So this undercut fixing give us the actually good flexibility that we can attach the reveal panels, which is already the smaller in the size, because of this window is fixed many times at the edge of the concrete. So the stone size will come of this reveal is around 100 or sometime 60 as well, because the jam stone is always stopped behind the main panel in the front. So this is why these jam panels are always smaller in the size. Hence this putting any kind of the framing at the jam is not possible due to the fastener, actually the edge distance of the fastener, that is the critical part here. So these reveals are we can use actually with help of undercuts, and there is a slots we are actually providing in the reveal, so the tolerance of this stone can be accommodated, as well as later on the expansion of the stone as well. Then I will like to show you the fixing of these verticals, like how the structure is being fixed on this for the stone cladding. So first, actually, the brackets are being fixed on the wall. And then actually you have to see the left side of the sketch, where the bracket will be fixed first and then the vertical frame being fixed. The dead load of this bracket only one. The rest of the bracket will be act as a wind load bracket. And we have actually provision, means we need to give the provision as the structure is not always in the one line. So we have the provision for the plus minus in and out tolerances of the concrete, and that can be accommodated in the bracket. So actually this system can work like the cavity can be, we can actually have right from 60 to even we can go up to 190 or the 200 mm plus minus tolerance also can be accommodated in that. And we always believe to give the aluminum structure only, as it is a ventilated facade where the moisture or some amount of the water can enter inside. Hence we never give the any kind of the framing which is other than the aluminum. Definitely the SS316 we can provide, but it will be very, very costly. Hence the aluminum structure is being used to avoid those problems. And this is how you will see around the window there is no any framing is installed because we are using the reveal panel. Then once the vertical rails are fixed in a proper line, after adjusting the in-on adjustment, the side tolerance, then the horizontal rails are being fixed, which will receive the stone panel later on. The horizontal rails definitely we need to fix according to the modulation of the stone. These rails also we have to give the vertical tolerances, especially while the laborers are fixing. They may shift the rails up and down, as well as it is possibility that they can fix it inclined way. So I will show you the next slides how those adjustment will be accommodated. This is one of the another actually pattern that you will see that on the left bottom side corner. This pattern, like the architect has given the highlights of the panels, which is actually smaller in the size, and also it is shifted joint. The horizontally, what the joint is shifted horizontally. So these framings in the undercut fixing, such type of the framings also can be done very easily. So this is how the framing of this one is done, and this is floor to floor. So the dead load is transferred in the concrete, and only the wind load is transferred in the block work. Depending on these fixings are totally depending on the wind load. So that structural calculation we need to do it, and we are actually doing the structure calculation as per the project specific requirement. So this is how the actually shifted panels we are seeing. The framings are this in the one of the floor there is a different vertical rails, and in the middle the additional rails are fixed to receive this pattern of the stones. These stone panels, generally we have if it is a regular standard panels, then we have the 4 fixings. In that 4 fixings, the upper 2 fixings are transferring the dead load of the panel, and the bottom 2 panels are used for transferring the wind load only. Plus, it is allowed for the thermal moments. As Mr. Jarek shown that the thermal moment and the thermal expansion is the big challenge in the rain screen system, which can actually break the panel, or it will get it can actually come out from the facade as well. So this the load bearing fixed even this system is good enough to in the seismic condition, as we are putting one locking screw in the clamp here, so that it will stop the crawling as well. So this stone panel is one, the one clamp is actually fixed. The remaining 3 clamps can actually move actually sideways, and the bottom can move vertical ways. This is the actually 2D drawings, which is showing how the dead load of the panels is transferred to the structure. If you see the detail number 035001 in the section, there you will see there is a grub bolt. These grub bolts are transferring the load of the stone to the rails, which is fixed to the structure of the building, and the clamp is fixed by using the undercut anchors. So these undercut anchors, nothing but it is actually kind of the fasteners only, which is used in the stone. So to fix that one, actually there is a methodology, and there is a system that I will show you in the later stage at the end of this presentation. And the locking screw, as I told you, that the locking screw will be only in the one of the clamp at the above panel. In the one panel at the above there are 2 clamps. In the only one clamp will be locking screw. The other clamp does not has any locking screw, but both clamps will have the grub bolt, which can be transferred the load to the rails, and from the rails it will be transferred to the verticals, and from there it is transferred to the bracket and then the structure of the building. This is the detail showing the expansion of the clamps. So here we can actually provide the gap to allow the stone panel to expand due to thermal or the building moment. And the verticals definitely also need to provide the thermal moment because of the temperature difference, and plus building moment as well. So this is, you are seeing here the cavity, which is we achieve 170 mm, and this cavity can be adjusted plus minus 25 as the site tolerance or this concrete tolerance. This is the 3D view of that structure, which I have shown as a horizontally shifted panels. Now I will go to the videos which are actually showing you how the undercuts is being done in the panels. So this is actually thinnest panel. You will see the undercut is being fixed to that. It's a 12 mm thin stone only. Undercut drilling machine has various technology. Actually, each company has different one. This is our company's model, and it is very light in the weight. It can be very easily actually operated because the weight is very less, and this will be used on the site, as well as there is a provision we have. There is another video I will show you now. This is actually, this video shows that how the undercut is being done in the stone panel. Then there is a next step is coming, that how to fix the undercut in the stone. So we have our own method, whereas there is a traditional method. Some companies follows that they put the undercut and put the hammering from the top of the bottom of the stone. So what are the issues with that? That also I will show you. I will show you through the videos. Actually, this first part of the video will show how the stone generally it was the undercut was fit in the stone by hammering the undercuts to expand inside. And the disadvantage of that, breakage in the stone. Use the lesser force, still there is a possibility the chip off is happening at the back of the stone. So there is a possibility that if someone has actually putting the less actually force, then the anchors may not get expand correctly inside the stone. That will again give the problem that the anchor's resistance force in the stone will be reduced, and it can actually it is risk to failure of the stone while after the installation. So another files I will like to share that how the big facade. There is actually the big, then architect can actually choose a bigger facade stone as well, like floor to floor height stone as well. Because the undercut, there is actually possibility that the undercut can be fixed in the middle of the stone, as everyone aware that the major wind load will act and the major forces will be created in the middle of the panel, so the deflections are the more, and that will cause the breakage of the stone. So hence this undercut actually system is providing us the advantage from breakage to control that actually deflection by fixing in the middle of the panel. This is actually the floor-to-floor panels.
GRC.
This is GRC panels. And you see these actually all the clamps are fixed in the middle of the panel as well, which is actually this type of fixing cannot be performed in the pin type or even in the curve type as well. The pin and curve type is possible to do the fixing on the edge of the panel only. Then I would like to actually show one of the building actually in the Gift City, which we have done with this system. Gondola is being used actually to do the rail fixings, vertical fixings and the stone fixings. These all are the black granite. Thank you very much. Thank you everyone for listening us.
Thank you, Jitendra ji. Thanks for excellent presentation on the topic, which is a very highly specialized work. And we have received lots of questions also. So I'll read one by one the questions and request both of you to answer the questions. So let me start from the top. I think the question has been answered, but I can repeat the question. This question is from Mr. Jagan. He's saying when we are fixing granite on dry walls, external surface by adhesives, after several years, debonding issue occurs. Saying when we are fixing granite using adhesives on external walls, after several years, debonding issue comes up.
Yes, this is what I tried to explain in this webinar, because granite is not vaporable. This is soft stones in general, GRC, UHPC, I'm not sure, but we have tested the resistance for the vapor, and granite is not resistant. So I know that this is fixed on the wall, and after several years it falls off. Yes, this is the phenomena I explained, that the vapor water goes through the wall, through the barrier, and then just before on the layer of the granite it stops, it's changing into water, and then during thermal cycles it's just destroying this bonding. That is a common situation.
So can we say, I'm asking in continuation of this question, can we say if we are going for ventilated facade system, as you explained, this problem will be reduced to a great extent?
Yeah, the problem will not exist, because the rain screen is the stone is fixed away from the wall, and it is fixed mechanically.
Okay, so the solution to this problem lies in using ventilated facade system, using backup frames and clamps, as you explained, right, sir?
Yes.
With undercut system.
Yeah, so avoid even ceramic is also not vaporable. So if you glue this to the wall, the situation can be the same like in the granite. soft stones, limestone, travertine, sandstone, GRC tiles is okay to use it, and harder stones like granite, basalt, ceramic, glass, for example, also it is not allowed. It's not recommended, let's say.
So you are saying it's not recommended to use mortar or adhesive for fixing ceramic kind of stone like granite or ceramic or glass using the mortar. It's better to go for ventilated system, right, sir?
So
Next.
one disclaimer. Someone can ask, okay, how it is happen when we glue, when we fix brick slips? Yes, you can fix brick slips which are not when they are glazed, not permeable. But brick slips, you have 52 pieces per square meter, and the proportion between joints which are vaporable and the tile which is not vaporable is completely different. Today, projects are going direction to the biggest panel possible. So there is, and even thinnest joints. So you cannot compare these two solutions. That I just give this disclaimer.
The next question is from Mr. Abhinesh. You have covered in your presentation by reading a question. Please explain the fixing arrangement for 3-meter panels. I think I've already explained in the videos, but you can repeat it.
Actually, for 3-meter panels, definitely the engineering has to be done. And it is, yes, it is very possible to use the 3-meter panel. We can actually add the fixing in the middle of the panel to avoid its breakage and all. That is the specialty of the undercut system.
Yeah. So for 3-meter panel, we have to invariably go for an undercut system and using proper design and the system which you are recommended, right, sir?
Yeah.
Yes.
Okay. The next question is from Mr. HR Girish. He's asking, there are hundreds of fasteners on a large building facade. What method of quality assurance you should use to ensure that these are firm enough and so as not to cause safety issues? I'll repeat. He's saying we are using hundreds of fasteners in facade system. So what quality assurance we have to take up so that these clamps or these fasteners they remain safe and we don't have safety issues in long run.
Okay. For this case, actually, there is a factor of safety as well as given in the design. So the factor of safety is being used here is the double. Plus, we are doing the pull-out test in the undercut system. The pull-out values are coming to the stone are much higher than the requirement. Additionally, there is a factor of safety as well. So this is all covering the issues of the poor workmanship. And our system actually, as we shown our expansion of the anchor, which is giving very minimal chances of the failing of the anchor due to our method of fixing the undercuts. So this is why actually we said choose the right way.
Yeah. So I think the answer lies in answer to Mr. Girish's question lies in, first of all, we have to choose the right system, right? Second, the clamps which we are using, we should have from the good companies, where we have all those factors of safety like you just mentioned. And finally, when we are doing an installation at site, we have to do those precautions like we do the pull-out test and ensure that we are getting the desired results. Am I correct, sir?
There is one more point because which is very important. We are training people, also explaining all these issues on site. So this is very important because we are not only system supplier and finish that our job is finished. We go to the site and our technical support is there, controlling them, looking for the important points of installation, of drilling, and so on. Also, we have systems, tools to check the quality of the hole tolerances, and so on and so on. So the aspect which is very important, thank you for this question, but also one hole per 100 has to be tested by default. So, but as Jitendra said, very important is this larger margin of safety which is giving the undercut. This is a big difference between the pin type curve and undercut.
Yeah, so right is the workmanship, the right trained people and the right tools are also important in this aspect, right, sir? Yeah. The next question is from Ravinder Singh Verma-ji. He's asking any insight into the use of 9 to 15 mm thick vitrified tiles of about 800 to 1200 mm size in panel size of 800 mm to 1200 mm, thickness 9 to 15 mm in the facade cladding.
Yeah, so considering this is ceramic, I understand, right?
Yeah.
So if we have 9 to 15 millimeter ceramic, usually we are using 4 undercut anchors per panel. From the top is 100 millimeter away, from bottom 150, and from sides 100 to 150. But it depends also where we apply this panel. If this is first floor, second floor, and there is no major wind load, then 4 anchors should be enough. Maximum, I would say 6 anchors. Now, important is the socle panels, because they are exposed to crowd load, and in this case we need to make analysis, or in this only area, and this panel shouldn't be using more anchors or longer relays. So the solutions is there. We just need to know what kind of detail we are talking about.
Yeah.
But if important is one point, considering the fixing, so combination panel and fixing points, this is the weak point is the panel, because the wind which is acting on the panel wants to break it, right? So the flexural strength of the panel is the weak point, not the undercut anchor. We can install 3-meter panel only on 2 undercut anchors, and this is enough to carry this panel. But because of wind loads, we need to make the fixing grid much tighter. It is possible. You saw that panel 6.3 by 3.6, we were using 72 fixing points. So the solution is there. We just need to go deeper into details.
Thank you, sir. The next question again by Mr. Grish. He's asking, please share your views on periodic inspection of fasteners, which is a tedious yet essential practice.
Yeah, so yeah, this is a very good question, because in fact, periodic inspection of fastener during the installation already we discussed. This is 1 per 100 by default. But now the question is how we could be sure that the facade is safe when we see only front piece, front surface. We don't see what is behind. It doesn't matter if this is pin, kerf, or undercut. We want to be sure that the cavity area and there is no breakage from the backside. And in this case, I think you can answer this question, how we can inspect the cavity.
The cavity inspection, actually, when the facade is being installed, our quality engineer always check it is being checked by using actually that micro camera. They are putting the camera behind and seeing all the fixings are secured, because our system is the mechanical fixing. Once it is already secured, then there will be no much changes in that mechanical fixings, even in the longer period as well.
So basically,
but also important is that we, in our system, we can dismantle any panel
at any time.
At any time. So it is possible that the facade can be again covered by scaffolding because of many reasons. Sometimes there is cleaning, inspection. Sometimes they want to install some new advertisement, I don't know, text or whatever. So they can this panel can be dismantled and installed again. So this gives you this chance to inspect facade. In fact, there are coming regulations which require to inspect the facade 2 times a year. So this will be very important point to have the chance to dismantle panel.
Thank you, sir. Another question is from Mr. Joseph Silvera from Goa. He's asking, do you feel the stone cladding could sometime pose risk to human life in public places due to fixity and thermal problems? Do you feel the stone cladding could sometimes pose risk to human life in public places due to fixity and thermal problems? Basically, he's asking the stones falling down because of fixity issues and thermal reasons, as you explained during a presentation, then it can be a risk to public.
So I would say this way, that this is not particularly stone, because I observe many malfunctions. In my presentation, you saw the first building, which was high. Many panels will fall down. These were ceramic panels. Few years after installation. So let's say that I would recommend to inspect facade. Yes. If we observe that panels fell from the facade, yes, I observe, and this is not. It happens all over the globe. This is not. I show you in the presentation panels which are protected in the continent in Europe. Here you can find also panels. So this is not related to particular climate conditions, but this is related to the installation control or system solutions. And again, I'm coming back to this large margin of safety considering the undercut anchor.
Yeah, so answer, yeah, this if I look at a say customer or a public, the risk is definitely there. That is why we have discussed today all the systems and all the safety margins which we have to take. That's why we talked about ventilator system, we talked about thermal forces and wind forces and all the forces to be taken account, so that we minimize the risk of life, as Mr. Silvera has just raised the point.
I would like to just add that about 2 years ago, when I started to summarize the quantity, when my company was asked for facade replacement in a small country, okay, not small, but it's small in relation to India. So in Poland, I got inquiry in total in 1 year about 40,000 square meters. Majority it was office buildings and shopping malls. So size of the facade was between 3,000 to 6,000 square meters. And every this facade was made on the pin type. So I don't get me wrong, this is not the pin type is wrong and the undercut is good. I mean that each system I also proven in my presentation that is working. We need to just follow rules and technical limitations has to be taken into consideration. But definitely the undercut is giving you much more safety. So by that, I mean that even installers have more comfort, that whatever happens, they can make majority, let's say, cross sometimes the limitations, but we still have a lot of safety.
Okay, sir. Next question is, can we use undercut system on internal walls? This is a question from Mr. Gautami M. Can we use undercut system in internal walls?
Definitely, we can use the undercut system for the internal wall. There is no issue at all.
Next question is from Mr. Yatin. He's asking, which grade of aluminum is used? Is it 6061, which is easily available, or 6061 is easily available or not?
It is available, easily available, and same being used.
Okay. Next question is from Mr. Milind Rajhans from Civil India. He's asking, is it beneficial to use dry granite cladding instead of ceramic tiles from heat insulation point of view? Is it beneficial to use dry granite cladding instead of ceramic tiles from heat insulation point of view?
For heat in the Rhine screen, I don't think it plays any big role, because the panels are away from the construction of the building. The only point is that usually ceramic is thinner. It is much stronger material than granite, but it's also usually thinner, let's say 10 millimeter, 8 millimeters. So when it's more fragile, it's more difficult to make undercut holes in this material, because I also observed some question how deep we drill. In granite, we drill usually 15 millimeter deep, but if we will drill 14 or 17, this is not a big deal. But if you have ceramic, there is not much space, so you can drill 5 millimeter, which is very thin, and every half a millimeter already plays a big role. So in granite, you will have much more comfort during installation.
Okay. So next question is again from Mr. Gautami. He's asking, in granite, will apply epoxy epoxy, basically it's talking epoxy coating to avoid water absorption, but still debond will happen. What I understand is asking if we are doing epoxy coatings on the granite for preventing the water absorption, will it have impact on debonding also?
So I wouldn't use epoxy at all, because epoxy is in general this type of material, they have much bigger expansion, 5 to 8 times bigger than the stone. So if the stone will, temperature of the stone will increase such a way that the panel will grow 1 millimeter, so the ceramic, the epoxy will grow five times more. So the first page of my presentation of this building, where there are holes, the ceramic panels which fell down, the story is very sad, because at the beginning they were using travertine panels filled with resin, and on the pathwalk you could see some chips, and that was the reason to replace the facade. The inspection showed about 600 fixing points to replace. I mean, I don't mean fixing points, but 600 points which were causing some immediate or delayed action. So definitely the epoxy will, I wouldn't use epoxy, but this is my personal. You need to ask the epoxy supplier, maybe they have much better technology right now or different solutions. But epoxy will not prevent the water absorption much, I think. Better would be going to sealant.
Okay, sir. The next question is, this is the second last question. How is clamp fixed to stone? You have already shown the video where you have shown how the clamp is to be fixed with undercut. Depth of screw or bolt, or is it adhesive?
By screw only. It's a mechanical fixing. Undercut is completely mechanical fixing. We, as Mr. Jarek shown, the glue is not used and not trustworthy, and it has many criteria. So the mechanical fixing only we use. The undercut, as I shown in the video.
I think the last question we'll take up is, I think few questions you have already covered in other question answers we have already discussed. This question is from Varun Patel. He's asking, do you consider eddy currents generated by wind in design calculation of the framing system? Do you consider eddy currents generated by wind in the design calculation of the framing structure? Basically, see, what he is asking is, when we are designing the facade of wind load, so in wind load we have a condition which is, we call it eddy currents. So which is like a circular kind of thing. So do we go by that consideration? I think the answer of this will lie in IS 875 for wind load. It gives us the criteria for how to calculate the wind load.
Yes.
It will come from there.
Yeah, it's completely depend on the what actually, as
Location.
per what location and the location and the what wind speed, and according to the standard actually. That is all the criteria we are considering in the design, in considering the while designing the facade actually. Sometimes some consultant even asking to get the impact load at the bottom panel as well, or the peoples, where the peoples are more active actually at that location. So that is also we are considering, and seismic load as well.
So I would add only that loads on the level, let's say 2-3 kilonewton per square meter, this is nothing special. I mean, nothing huge. We analyzing sometimes very challenging conditions where the loads reach 7 kilonewton per square meter. This is huge. I don't know, maybe not directly answer. This is the answer to Mr. Varun Patel, but gives some idea about the levels which can be reached.
Okay, the last question I'll take up, it is from Subhajit. He's asking, after the installation process, is there any need for inspection on any basis to ensure functionality, especially after any calamities? I think you have already answered, but you can repeat it.
During
After you-
actually during the installation, the inspection is must actually, because these the labor contractors are always actually getting changed. The same labor will not be there from the start of the project till the end of the project. So every periodic inspection must be done. And as for the about these any cyclones, after the cyclones, it is better if we check, but it is depend on how generally the loads actually consider according to that, and it is better if there is any inspection is done.
But again, because of vibration also sometimes we can use, but this is very specific, project specific question, I think, because sometimes we can use spring washers or additional some chemicals to protect the threads, right? Unscrew. This is locking, yes.
Yeah, thank you, sir.
One more point. There is many questions about the epoxy, but in general in stone we are using polyester resins, which are half resin to the hardener, half, so which is much better material than epoxy. Yes.
Okay. So we close the questions. We have covered all the questions which were raised by our participants. So now we are coming to the end of our seminar. So I request Yatin to say vote of thanks.
I would like. Sorry.
Yeah, Jarek, you want to say something?
Yes, I would like to just share that for all attendees, wanted to thank you, and for you guys, we prepared some special surprise. You will get at the end the link to the movie, which is our internal company movie about one of the details which will help you solve maybe a few problems, which are major problems related to the so-called panels. This is not public material. This is our internal material. So I think will help you make better projects.
Yeah. So what we are going to do, actually, we have the email ID of all the participants. So through the email, we'll be sending the links what Mr. Jarek just now said, and that is a specialized material on claddings, ventilated facades. So we'll get it, and you can augment your knowledge further on the field. We'll get it by email.
Yes.
But
please use some comments if you can. After that, it will help us to improve the safety of rain screens.
Yatin is conducting a poll now. Yatin, please take over.
The second poll is live now, sir. Did you experience facade malfunctions or damages? I request the attendees to please vote.
We request participants to go into poll and answer the question which is raised in the poll and give their answers, and then we'll conclude.
I think that after this webinar, more people will.
We request participants to give their answers in the poll. Okay, Yatin, we got the idea. You can declare the results, and then please say the vote of thanks.
Thank you, sir. Dear speakers, on behalf of ICI New Delhi Center, we would like to thank each one of you for sharing your knowledge, insights, and experience with all of us. We learned about the advantages of rain screen ventilated systems, along with installation system methodology of undercut anchoring system. It was a delightful experience. Thank you so much. To our attendees, we also thank our attendees for their participation during the webinar. Your insightful questions helped us to make it an interactive experience. Also, thank you for taking your time out on a Saturday. Finally, I would also like to thank our chairman, ICI New Delhi Center, Mr. Pradeep Garg, for the enthusiasm and constant guidance to all of us for organizing this webinar successfully. Thank you so much, sir.
Thank you very much. And it's time to close. And we'll be conducting a similar webinar in maybe next month or another 2 months down the line. And we request you to join us and show the similar enthusiasm. Thank you, Jarek, and thank you, Mr. Jarek, you want to say something?
Yes, thank you very much to all of you. And if you have any questions, our team, Jitendra, and our chief, Mr. Vikram here, we are at your disposal. So any questions, please write.
Yeah, you can email. We'll close it now. Please email your questions. You have the email ID. We'll forward it to the Blick experts, and you'll get the replies on your email now. Is it okay, sir?
Perfect. Thank you very much.
Yeah. Thank you, and we close the webinar now. Thank you all. Thank you very much, sir.
Thank you.
Bye.
Bye.